EMA 4003 final project, I will be talking about composites. So firstly, what are composites? Composites are a particular type of material made from two or more chemically distinct materials that, when combined, form a new material with improved properties. We have two categories of composites, natural and synthetic composites. So an example of natural composite is wood. It is made from cellulose fiber and lignin, with the lignin as the matrix or natural glue, and the cellulose is the reinforcing material. And then a man-made composite example is reinforced concrete, where we have steel bars as the reinforcing material in a matrix of concrete here. So just to dive deeper into what is a composite. Most composites are made up of two materials. One material is the matrix phase and the other is the reinforcing phase, which are usually fibers, sheets, or particles. The matrix acts like the glue to hold the fibers together, and it protects the fibers from environmental and external damage, and the fibers provide strength and stiffness to reinforce the matrix. So when a load is applied to the matrix surface area, the matrix transfers the load to the fiber, and the strength of the fiber and toughness of the matrix helps the material resist cracks and fractures. So this is a pictorial representation of a composite structure. We have the matrix, it protects and transfers load between the fibers, and there are three common matrix types. We can have metal matrix, ceramic matrix, and polymer matrix composites, but we can also have different materials or more materials as the matrix. Then we have the reinforcing material, which provides strength and stiffness. Examples of the reinforcing materials are glass, basalt, natural fibers, carbons, and many more materials. And by combining these two materials together, you get a new property with a new material with properties superior to the individual components, sort of like a super material. And just to talk more on the composite structures, you can actually have your composites, as well as having different materials, you can make your composite structure in different ways. So you can have the particulate reinforced composites, which are made of hard particles, constituents scattered in a soft matrix. A very good example of this is concrete, which is gravel embedded in cement paste. And we could have fiber reinforced composites, which are composed of stiff and strong fibers held together by a matrix. As you saw in the previous picture, these fibers may be long and continuous. This is an example of a unidirectional continuous fiber reinforced composite, or they may be short and flaky in random directions. Then for the last common composite structure, we have laminated composites, which are made from completely bonded thin elementary layers. This type of composite is the most encountered composite in high-performance structures. And depending on your functionality, you can choose different materials and different structures to use to make your composites, and that's why composite materials are very versatile, is they give you that design flexibility. Applications of composites. Composite materials are used in a variety of industries. To name a few projects we see composite materials in, we have buildings, bridges, boats, and sporting goods. Industrial composites are used in industrial applications where we need corrosion resistance and high performance in adverse environments. And examples of products where composite materials are used are piping, fume hoods, water treatment plants, and others. And advanced composites are used in aerospace and aviation industry due to their high structural strength and lower weight. Advantages of composites. Composites are widely used in our everyday life and they offer many benefits. Some of the key benefits are resistance. They have long-term resistance to severe weather conditions, high temperatures, and harsh chemicals, and this makes them perfect for applications that face constant exposure to salt water, toxic chemicals, and temperature fluctuations. Lightweight. So composites are lighter in weight compared to other metals or materials like metals and ceramic, and this this is very beneficial because their strength to weight ratio is high, and it's really beneficial in the aviation and automotive industry where fuel efficiency is desired. And it also makes it easier to transport and install composite materials in the infrastructure industry. To give you an example, an idea of how lightweight they are, reinforced carbon fibers can be up to 5 times stronger than 1020 grade steel and only one-fifth the weight, which makes them perfect for structural purposes. They are also very durable, they have long lifespans, and that makes them commercially viable. Disadvantages of composites. When compared to wrought materials, composites are more brittle and more easily damaged. They are also more difficult and expensive to repair compared to other materials due to their specialized material requirements, and it's also much harder to detect failures in composite materials. Look into the future. So, what is the future of composites? Well, I believe that green composites could be a possibility in the future as polymer composite materials are made from non renewable resources like petroleum, and synthetic fibers are really energy intensive. So, there has been a push to develop green composites. And what green composite basically it's a composite made of natural fibers and bio based resins as the polymer matrix. So for natural fibers, the polymers, the composite would be made out of hemp, flax, kenneth instead of synthetic fibers. And for the polymer matrix, the composite would be, instead of produced by petroleum, will be produced from starch, vegetable oils, and protein. And I believe that 100% bio-based composites with improved mechanical properties will be a possibility in the future. Thank you. Do you have any questions?